All right. So let me think. So I have that as that time. We're going to go ahead and get started. There are no, let me see, let me make sure the stream is working. I think my first two classes, the audio wasn't working, but I think it's working now. Um, as far as announcements, it's just kind of the same thing. Like exam two will open up next Wednesday. It's going to be just like exam one, but there'll be an oral component, right? So it'll still be on Pearson. It'll be pretty much the same thing, just put it on sections 1.4, 1.5, and 1.6. And then with the oral component, what I want to do is schedule like maybe 15-minute windows, for each person. I'll make that soon. It's just not made right now. And then, so when we're doing the oral exams, what I'm going to need from you all is to be able to see your face, like while we talk. I'll probably stream it as a recording, but I'll make it private so that way, I just need it for records, for my records. Um, yeah, and so what we've been doing is like going through. So the way I kind of do the exams, I basically go through all the questions that are available on Pearson, and I like pool the questions together. So that way, like when you take your exam, is each person, you pretty much get a different exam each time. And so what we've been doing is I've been trying to go back and see, can we find some of those questions that could potentially pop up on the exam that were not necessarily assigned in your homework, right? So I'm going through a few additional questions. You're not responsible for them, but you could see them on the exam. And like, even though it wasn't exclusively in the homework, the content and the concepts are still the same, right? So I felt like, at least if you had seen it before, hopefully you can take advantage of that thing, right? Okay. Trying to just let people in. And like always, if you have questions, comments, or concerns, I suggest put it in the chat. I'm going to go ahead and suppress my audio so that I can focus. If you have questions or concerns, put it in the chat. And also, I just want to remind you that my intent of the class time is really just supposed to be a Q&A, question and answer. I just go through the homework as a courtesy. But we can go to any other question. We don't have to do the questions I'm working on. And also, just as a reminder, if you email me and I haven't responded, just ask me during class time, all right? Because this is really like quote unquote office hours. But yeah, that's the long and short. Let me check the chat real quick. Yeah. So, and we are doing asynchronous. The main thing I need from you all on a day to day is just to check in, get your attendance credit. You're responsible, the video, all the homework for the semester is available, so you can get ahead if you like. All the quizzes for the semester are available. The only thing that's not available are the exams. Also, I stream these sessions barred or uh, outside of any like unforeseen like technical difficulties. I stream these sessions, right? I think this morning I didn't get those audios out. Just it was just technical difficulties. And I didn't realize until like I got to my third class. But generally, I stream these sessions. So yeah, it's asynchronous. Just get your attendance, and then the rest of the time is up to you. You're an adult. I let you make a decision. I'm not going to hold you. I'm not going to waste your time. Um, so I'm just going to hop on over to Pearson and kind of see, can we find some of these questions that could pop up on the exam that's not necessarily in the homework. Let me see. Yep. Have a good day. It's okay. Let me get this student right here. Cool. Okay. We had these interactive questions. Let me see. I couldn't get the interactive figure to work, but we were able to kind of reason our way through it. So we're given this function. It says that okay, so for any decreasing function, we have some function that's decreasing. So that means when you trace it left to right, it's going down, right? If f of 5 equals 11, then which of the following is true? So we're given that the function is decreasing, and when x is 5, y is 11, then now we're considering f of 3. Notice that the second point is less than the first, right? So since the function is decreasing, it's kind of the reverse of our intuition. So since we have x2 is less than x1, then y2 should be greater than y1. All right, so this y value should be greater than 11. It should be the reverse because the original function is decreasing. Now, if I need to draw like a corresponding picture or explain that another way, just let me know and I'll go back and like try to do that one again. I couldn't get the, now I'm pretty sure if I like log out and log back in or something like that, I could probably get this thing to work, but over which interval is the function constant? And I don't think that one I don't think I can answer because I don't have the image. Yeah, I'm not going to try that. I'm going to go to the next question. It's just because I can't get the image to work. Let me see, I think I can answer this one. It says on an interval in which f is constant, let me get this student. Cool. Got him, coach. Okay. I'm totally sleepy. By the time I get to you all, I'm ready to take a nap. I guess I'm getting old, but I've always been that way. So it just seems like it's getting worse. So I'm like, whatever. I just try to keep the energy up. So it says on an interval in which f is constant, so we have some function that's basically a flat horizontal line. If x2 is larger than x1, then which of the following is true? So if you're on a flat horizontal line, the y values are going to remain constant no matter where you are on that constant interval, right? So it should just be A. Cool. My attendance thing is working so much more smoothly, so much better than before. All right. Okay. So we knew that was correct because we were working on a constant, a part of the function where it's constant. Let's see, on the interval 1.5 to 5, in which f is constant, so again, the function is constant on this interval. If f of 3 equals 14, then which of the following is true? So now we're considering 4. Notice that 4 is on this constant interval. F of 4 should also be 14. They should be equal. All right, constant means that the y value stays constant no matter what x value you choose for that interval. Okay, hopefully this is okay. And and again, these questions could pop up, so that's why I'm like taking some time to see can we identify these types of questions. Complete parts 1 through 4 below. It says find the value of f of -4. We can't see it. I might have to skip this one. Yeah. I'm going to skip this one just because I can't get the figure. I probably need to like log out and log back in or something like that. I'm sure I could get it working, but I'm going to skip this one because I can't see the graph. I have to skip all of these. Okay, let's see, can we do this one? What is the value of f of x plus h minus f of x? Okay. So it says we have the x is 4.5. It says set the x slider to the point x equals 4.5, the x plus h slider to 6.5, and then use that to complete this. Oh man, but we don't have the function. Man, if we had the function, we can answer that question. Let me see. Can I see it here? Yeah, I think I'm gonna have to skip this one. I got to get past these interactive ones. It's just because I can't get it to open right now. Okay, can we do this one? Use this. If x is 3 and h is 1.5, what's the slope? Okay, we might be able to do this one. Okay, we're going to give this one a go. This one looks interesting. Let me take some notes and then I'll walk you through it. Paper. Okay. So here now you don't have this assignment. This is just something again that I created so that we can try to answer some of those other questions that you might come across. On this assignment, this is question 58. This comes from section, where's the question ID? Let me get this student. We might not have a question ID for this one. I'm just gonna say, can I see it here? Let me see if I do it like this. No? Oh wait, I saw it. There it is. Interactive figure 1.4.24. Okay. Okay. So let me see. This is interactive figure. Where'd it go? Yeah, 1.4.24. 1.4.24. Okay. So we are given that f of x equals x squared minus 4x plus 10. Okay. We're also given that x equals 3 and h equals 1.5. Okay, and then I'm going to say what's the slope, and I'm going to put a question mark. Okay. So let's hop over to the tablet. Take a look at the notes that I just took. And I want to close this up. Okay. Let's see if we can get to the bottom of this one without the graph, right? So we have this f of x, and basically it's asking us to find the slope. So what's going on, we have an x, and then we have x plus h. So first let's identify f of, and this comes out of a difference quotient discussion. Let's first identify f of x plus h, all right? So f of x plus h, again, we're going to replace each x. First thing we want to do is replace each x with a blank set of parentheses. Okay. So then we got x squared minus 4x plus 10. And again, what we're doing here is replacing each x with x plus h, basically this blue thing. X plus h, x plus h, right? Okay. So let's expand this out and see what happens. So the expansion of the first expression is going to be x squared plus 2xh plus h squared, okay? We can distribute this negative 4. We'll get negative 4x minus 4h, and the plus 10 comes down, okay? So that's f of x plus h. So now we can do f of x plus h minus f of x over x plus h minus x, right? This is slope, which is it's essentially just finding the difference quotient. It's just finding the difference quotient, okay? So let me copy and paste. Copy, paste. So now we want to subtract f of x. So I'm going to see, can I get this to go ahead and fit f of x? So if we subtract f of x, we need to distribute a negative. So we're going to have negative x squared plus 4x minus 10. We had to distribute that negative. Okay. And then really what it is x plus h minus x, but then you should get some cancellations going on. So let's plug it into the difference quotient. So now after that, let's simplify. So this x squared cancels this one. This positive 4x cancels this negative 4x. This negative 10 cancels this positive 10. This negative x cancels this one, right? So notice that the remaining terms all have h in them, all right? So that's a good omen. That means there's a good chance we're on the right track. So let's go ahead and factor out an h from those remaining terms, okay? If we factor out h, then on top we're left with 2x plus h minus 4, right? On bottom, we're left with just h, right? So then now we can cancel these h's, and we're left with 2x plus h minus 4, okay? Let me see something. I think we were given h, right? H is 1.5, so we can actually plug that in. Okay, and I think we're given the x as well, so we can actually find that slope. So then that's going to be 2 times when x is 3 plus h is 1.5 minus 4. Okay. So then what we get, let's see, is 6 plus 1.5 minus 4. 6 minus 4 is what? 2 plus 1.5 is 3.5. Okay, so our claim is that when x is 3 and the change is 1.5, for this function, then the slope between those 2 points we get is this 3.5. Okay. All right. So we're going to take that result and plug it into Pearson. Plug it into Pearson. Plug it into what? Plug it into Pearson right here. I'm totally sleepy. We're going to do the best we can. Okay, so we got a slope of 3.5. Okay, I feel okay with it. Let's go with it and see what happens. Woohoo! I'm doing a little dance, make a little love. You know, I'm just you got to celebrate when you can, right? Let's go for another one. Let's go to another one. Describe the transformation. Okay, let me get the student. It's this one. Okay, need that to go cool. I'll let him in. So describe the transformations that produce the graphs of g and h from the graph of f, right? So f, the base function here is square root. We have this function g, this function h, right? Notice that these transformations are outside of our basic function. Let me make sure I'm showing for the people, the YouTube family. Describe the transformations that produce the graph of g from f, right? So if notice we added a 2 outside of our basic function, right? So remember that outside manipulations are generally vertical manipulations and they follow our intuition. So if we add a 2 on the outside, then what we do is we should move it up by 2, right? So it should shift up by 2 units up. What you could do if you weren't sure of that, you could graph F and then graph G and then compare and see, okay, what change happened, right? That's another way you can kind of, at least until you start catching the lingo. Describe the transformations that produce the graph of H from the graph of F. So we subtracted 4 on the outside. So again, outside manipulations are generally vertical manipulations and they follow our intuition. So this one should go down by 4 units. Okay. Let's try another one. So the base function here is x squared, and now we're doing manipulations inside the base function, right? So we added 4 on the inside on the first one and subtracted 5 on the inside on the second one. So inside manipulations are generally horizontal manipulations, and they're the reverse of our intuition, right? So if we add 4 on the inside, it should move it side to side. Now, since the positive x goes to the right, but it's the reverse of our intuition, this one should actually go to the left by 4 units. So 4 units to the left. Again, inside manipulations are generally horizontal manipulations, and they're the reverse of our intuition. So this moves into the negative x direction. Okay. And then the graph of h, it should move horizontal and to the right. Again, the reverse of our intuition. 5 units to the right. So it should be C. Okay, hopefully that's okay for you guys. Describe the transformation that produce the graph of G from the graph of F, and so on and so on, right? So the base function here is like absolute value. So that's like a V. Let's see. So the first manipulation we did, we multiplied the outside by a negative, right? Again, as a refresher, outside manipulations are generally vertical manipulations, and they go with our intuition, right? So if we multiply the outside of our base function by a negative, it's like all the y values go from positive y to negative y. The x values stay the same, but if we go from positive y to negative y, then the image flips, right? It flips vertically over the x-axis. So it reflects in the x-axis for part A. So then part B, if multiplying the outside by a negative reflects in the x-axis, then intuitively, here, let's not say that just yet. But if we multiply the inside by a negative, remember, inside manipulations are generally horizontal manipulations, and they're the reverse of our intuition. But in this case, you know, instead of flipping over the x, it's going to flip horizontally over the y. Okay. Okay, describe how the graph of the following function can be obtained from one of the basic graphs. To obtain this graph, start with the graph of y equals, it's going to be 1 over x. That's one of the basic functions. That's called a reciprocal function. Okay. So now, if we start with 1 over x and we want to finish with 6 over x, that means we multiply the outside by 6. So multiplying the outside of our basic function by a number larger than 1 is going to, okay, outside manipulations are generally vertical manipulations, and they generally follow our intuition, right? So multiplying the outside by a number larger than 1 is like basically the x values stay the same, but the y values are go higher, right? So that's going to cause a vertical, we're going to stretch it vertically because it's outside manipulation by multiplying each y value by 6. I feel like we need to do a few more of those for that to sink in. If you guys are still present, you know, because I get the whole thing. I just want to see you guys do well, and but we still got to keep the rigor as best we can. So given this basic function of f of x equals x cubed, we want to list, now we have multiple transformations in one go, right? So whenever we're doing multiple transformations, my recommendation, work your way from the inside to the out. Work your way from the inside to the out. So for instance, if we start with x cubed, it's like a S-shaped graph where that middle part is on the origin and it's generally increasing. Now the first transformation is this -3. That's the innermost transformation. So if we subtract 3 on the inside, that means we're going to move horizontally to the left. Sorry, to the right by 3. It's the reverse of our intuition. So this says to go right 3 and then down 4. That because this is outside the basic function, it's a vertical change and it follows our intuition. So it's only 2 transformations here. This says go right 3 and down 4. 3 units to the right and 4 units down. Okay. I think there was some activity in the chat. Sorry, let me check the chat really quickly. Check the chat. So this review that we're going on right now, I guess for you all, because I know you don't have access to this, but you know, for review, you basically just want to go over sections 1.4, 1.5, and 1.6, right? I'm not really doing a study guide. Your homework is a study guide. I just want you to be aware that there could be questions asked on the exam that were not necessarily asked on the homework, but the concepts are the same. It's the same type of question. It's just not literally the same question, right? So that's why I'm going back and like trying to go through the pool of questions so that maybe we can see some of those that aren't necessarily assigned in the homework that could pop up on the exam. These are good questions. Let me make sure I got all the parts of that. And yeah, so this it's not really a midterm. It's just exam 2. That's going to open up next Wednesday, so a week from this Wednesday. It'll open up a week from this Wednesday, and it'll be due the following Monday morning at 9 a.m. And then also with all of our assignments, I just wanted to remind you that we get unlimited attempts at all of our assignments. That means homework, quizzes, and exams. And we can work on all assignments past the due date. It's just that whenever we work on something past the due date, the highest we can earn is a 90%, right? If you want to earn something higher than a 90, then you just need to earn that score before the due date, right? But I've totally had students that essentially waited to the last minute and got it all in. So they gave me what I needed within the bounds that we agreed upon, and so I was able to kind of keep them going. These are good questions. I appreciate the questions. Okay. So I think we got part A. So then part B, man, my girlfriend is like making some food. It smells so good. I'm just like, I just want to like eat and go to sleep. I'm being totally lazy, and it just smells good. Okay. It's intoxicating. Anyway, but it's not alcohol. So now. So part B. So yeah, we're doing multiple transformations in one go, right? So again, my recommendation is work your way from the inside to the out. So the innermost transformation, we have this +5 inside the basic function. So if we do +5 on the inside manipulations are generally horizontal, so it goes side to side, and it's the reverse of our intuition. So since we're adding 5 on the inside, that means it should move to the left. So it should go left 5 units, so 5 units to the left, so it has to be either C or D. We multiplied the outside by a negative, so now we're back to outside manipulations. Multiplying the outside by a negative should cause a vertical change, so it should flip vertically over the x-axis. So then it has to be D. And then we subtracted the 2 on the outside, so it should go down by 2. So this one should be D. Another thing that you could do, if you weren't sure, you could put graph just f of x equals x cubed, and then test out these transformations. I mean, that's kind of like brute force, and you would be missing the point, but you could get the right answer, right? And it's not about the right answer. I really just want you to think and try, and like, these concepts I feel like are not difficult, but it is a lot of information. So because it's information overload, that's why Morehouse is like dial back the course load for college algebra. The other thing I just wanted to mention, just be sure that you're working with Dr. Lamar. She gives me a report. I'm going to use that report to update like lab grades. Lab is like 10% of your overall grade, and basically whatever she gives me, I'm just going to use it to give a grade. And like honestly, as long as I see that you've been like doing the things that she asks, you're in attendance, you essentially get credit for it. It's kind of like an all or nothing kind of deal. But I feel like there was something else. Oh, and then like as far as midterm grades, so I'll put that after exam 2, and once I finish the oral exams, within whatever deadlines we need to hit for that. Let me check the chat real quick. So this is something I made to just go through with you all. You don't have access to this. This is just an attempt to try to at least shed some light on some potential questions that could pop up on your exam that's not necessarily assigned in your homework, right? So that's what this is. This is just something I created so that we could try to find some of those questions. And if you want to see other work with this assignment, you would watch. Well, the audio kind of went out from earlier in the day, but the stuff from today and the stuff from last Wednesday, that was when I started doing this. It should say like exam 2 study guide review or something like that. But this is just, you don't have access to this. So the only way you're going to get it is here and on my YouTube, right? Yeah. And yeah, I mean, it's there. So let's look at some more transformations. Okay, so the basic graph we have here is the cube root of x. That graph is just going to be like a sideways S. It's going to kind of like start out kind of flat and then like increase, and it's kind of like a sideways S. It's kind of narrow, right? So now if we want to go from F to G, how do we get to the graph of G from the graph of F? So notice we subtracted a 3 inside the basic function. That minus 3 is inside the root 3, right? The cube root. So inside manipulations are generally horizontal. It should move it to the right 3 units. So 3 units to the right. Inside manipulations are generally horizontal changes and are generally the reverse of our intuition. So it should go 3 units to the right. Okay. What transformation produces the graph of H? So H, we subtracted 3 on the outside of our basic function, right? It's very subtle, but they cause different changes. We did the 3 inside the cube root here on part G, and then we did the minus 3 outside the cube root on part H, right? So because this is the outside manipulation, it's generally it generally causes a vertical change, and it follows our intuition. So this should go down by 3 units, 3 units down. So it's going to be this one. Let's see, we got some more questions. Energy. Can I refer to you? Yeah. Yeah. So we are doing asynchronous. As long as you get into my Zoom, then you've gotten your attendance credit, right? So I'm not, I don't make you stay. It's okay if you leave. It's totally okay. That's part of the reason why I suppress my audio so I can focus, and that's just the agreement. Like, I think it's okay. I know about sometimes even I have technical issues. Like, it's just either the internet is slow or my device is moving slow for whatever reasons, and so I felt like a fair, a halfway point would be to make the class asynchronous. I know I have some colleagues that like They don't go live at all. They like just post everything and you just have to like work it out and go back and forth in email. So because we have a lot of extra time, the way that because as a result of the changes that Morehouse made to this curriculum, I'm essentially using like class time as like office hours to a degree. I know this sounds a little weird, but we have the time to do it. And so instead of trying to schedule other times where you may or may not be available, I know that all of you all are available now to, so if you need help or questions, we can actually talk about it during class. And I like it because, the same questions you have, I'm pretty sure somebody else has it as well. Right? So it kind of helps us all. It helps out everybody when you guys ask questions genuinely. So hopefully that helps. Okay, that was fun. Okay, so we're asked to graph this, right? So through transformations, notice we subtracted a 3 out. The basic function here, basic function is y equals x squared, which is a parabola. We subtract a 3 outside the basic function. Outside manipulations generally cause a vertical change and follow our intuition. So this should be basically a parabola that's been moved down by 3. So I'm going to click to enlarge the graph. I want to use my parabola tool. I'm just going to put, well, we know if we have a parabola that went down by 3, we know we have a y-intercept of -3. Oh, okay, vertical shift. We want to go down by 3, that's it. So I'm going to just put -3. Let me see what happens. Is it behaving properly? Let me delete this and start over. Yeah, that's fine. So I'm gonna hit my parabola tool and I'm gonna click on the origin, 0, 0. We want it to go down 3 units. So I'm gonna say -3 and hit enter or X to close this out. Yeah, see? So it looks like the vertex went down 3 units. The origin's here and went down by 3. I'm gonna hit save and check the answer. Let me check the chat. Yeah, we got some activity in the chat. Yeah, cool. Yeah. It's all good. It's all good. Yeah, just once you get into my Zoom, then I treat you like an adult. It's up to you. The rest of it's up to you. I meant to go to the next question. I'm totally faded. I don't want to keep it for more than 10 minutes, so we'll kind of hang out for like another 10 minutes. Okay, so more transformations, right? So the base function here is square root of x. The graph of square root of x is generally a side. It's like a sideways parabola, half of a sideways parabola. So if you think about the U-shaped curve, you turn it to the right and cut off the bottom half. That's generally the graph of square root of x. So notice we added this +2 outside the basic function, so that should cause a vertical change, and it should follow our intuition. So it should just be square root of x that's been moved up by 2, which is c. C is the only one that went up by 2 from the origin. Okay, point of origin. Okay, another transformation, right? Absolute value of x plus 7. The base function here is absolute value of x, which is just a v with the vertex at the origin. Now we added a 7 inside the basic function. So inside manipulations generally cause a horizontal change, and it's the reverse of our intuition. So instead of moving in the positive x directions was to the right. Instead of moving to the right, this should move to the left by 7 units. So I think the only one that moved left was B. Only one that moved left was B. Okay. Let's see. Graph this function, starting with the function in the library, then using the techniques of transformations. Okay, let me see if it'll behave the same way as the last one. So notice that the highest degree here is a 2. So we should be dealing with x squared, which is a parabola, a U-shaped curve. So I'm going to hit my parabola tool. I'm going to click on the origin to see if it do it the same way. Okay, so now this one basically wants us to, incorporate the transformation. So basically I'm starting with a U-shaped graph with the vertex at the origin. For a hot second there, I felt like a preacher. We want a U-shaped graph and that little stutter that the preachers. For a hot second, that's what it felt like. Okay, so now again, to kind of recap, when we're doing multiple transformation in succession, last term I was kind of playing with the students. I was like, What if I went a whole day just talking like a preacher? I just don't have the energy and focus to do it right now. But and I say with transformations, if you're doing transformations in multiple succession, the devil is a lie. Just throw in like a bunch of like church idioms or whatever, and talk with charisma and like heightened energy or whatever. I can't keep it going. Okay, let's focus. So we started with a U-shaped graph. We put it at the vertex already, so that's done. So we're fortunate. We only have 2 transformations, right? We only have 2. Hopefully you can see my cursor over here on the left. We're looking at this g of x, right? So working our way from the inside to the out, just like in life. Just like in life, you want to do better, you got to work from the inside to the out. I know we in the superficial society with the TikToks and the who-dads and the Facebooks, but let's get off the Facebook and put our face in a book. You know what I mean? Like stuff like that. Like I would just keep going. I wouldn't even stop. But anyway, so yeah, if you want to improve yourself, you're working. My recommendation is working away from the inside to the out, but that's not the only way. A lot of people are working away from the outside to the in, and it still works. As long as you just, the watch point of the universe is progress, right? As long as you're progressing, it's not my place to say whether one direction is better or more favorable over the other. I just chose to progress myself, working my way from the inside to the out. And what I mean by that is like focusing on like my emotions, or like being more emotionally mature, or emotionally savvy, being more patient, being more understanding of what people are going through, stuff like that. Versus some people choose to like focus on the surface, like they'll put on makeup and all that. And there's nothing wrong with it. It's just a different technique. If at the end of the day, if you get to that like nirvana or the place where you're really trying to be, who am I to look down upon one technique over another? That's not my place. I'm just doing the best I can with what I have. You know what I mean? And I acknowledge that everybody's essentially doing the best that they can for what they have. Okay, enough of that. Back on track. That's my favorite thing to do, is go off on tangents. So we have this U-shaped graph, working our way from the inside to the out. We have this -4, right? We subtracted the 4 on the inside, so that means it's going to move horizontally and it's going to go to the right 4 units. So we want to do a horizontal shift 4 units to the right. So I'm going to do 4 here, and then it went up by 2. So we want to do a vertical shift by 2, by +2. I think that's it. Let me see if I close this out. Yes, we went right 4 and up 2. That was the only changes. I'm gonna hit save and I'm gonna hit check. Okay, I think we got time for another one. I think we can get another one in. I actually do feel re-energized after my little channeling of the preacher or whatever, the pastor channel. Anyway, use the graph of the known basic function and the combination of transformations to sketch the function, right? So the basic function here is a reciprocal function. You actually can kind of see it over to the right. It has a horizontal asymptote and a vertical asymptote, and it looks like this little ninja star kind of looking image. But that's called the reciprocal function. So now, if we want to list out the transformations, there aren't really any inside transformations here. So then the first one that we consider is this negative. So if the image on the right is the original and we multiply the outside by a negative, that's going to flip it top to bottom. And then we subtracted a 1 on the outside, it should go down by 1 unit. So instead of the graph being in quadrants 1 and 3, when we flip it vertically, now the graph should be in quadrants 2 and 4, and then we should move it down by 1 unit. Let me try to get the correct thing, and then we'll check the chat because I see the activity. So part A looked like it moved to the left, so that moved the wrong way. Part B looks like it moved up, so that moved the wrong way. I think C moved to the right, so that moved the wrong way. The only one that moved down by 1 is D. I'm going to submit D and go with it. Okay, let me check the chat. We're essentially done for the day. Like, we don't have that much more. So the link to my YouTube, it should be one of those links. Like, I think we have, like, when you log into Blackboard, there's one main folder. When you open it up, you'll see, I think, like 8 folders. It's going to be like the 4th or 5th item. It's just, once you open up the main folder, you're going to see it on that next page. It'll say, or you could just go to like YouTube and search for like Beautiful Mind Pfeiffer. It's just a basic channel. I'm not, it's no icon or anything like that. It's a purple background. That's it. It's just there, but yeah. So those are some of the ways to get it. Cool. Okay. Let's do one more because we still got a little bit of time. This will probably be the last one though. I'll probably go depending on how quick it is. So the graph of the function, it says graph this function basically using transformations, okay? So we have two transformations. The base function here is x cubed. It's like an S-shaped curve, right? We multiply the outside by a negative, so that's going to flip it vertically over the x-axis, and then we go down by 9. So I'm going to click on the enlarge tool. So I want my cubic function, so that's this x cubed here. That's this tool here. I'm going to click on the origin. So we said we flipped it vertically over the x-axis, and then we went down. Vertical shift down, I'm going to put -9 here. Can I hit enter? Okay, I'm going to close this out, and I'm going to hit save, and I'm going to check my result. We got time for another one. This should be the last one. Hopefully it's not too long. Okay, multiple transformations, right? The base function here is x squared, right? So I'm going to go ahead and click on my graphing utility. If we're doing x squared, this one might be a little bit different than the way we're doing the others. Because I think if I click on the origin, it's going to want like additional points. Okay. So we need to account for the transformations. Let me delete this. So what I'm going to do here, I'm going to follow the vertex, right? So normally the vertex starts on the origin. I'm going to make my way through the transformations and try to keep track of the vertex, right? Just follow the vertex. Actually, I know exactly where the vertex is just by in this form. But we'll talk about how I know that already just by looking at it. We'll talk about that in chapter 2, because that's a whole thing. Okay, so but if we follow the vertex, right? If the vertex of this parabola starts at the origin, and we work our way from the inside to the out, so this says to go what? Right 4. We go right 4. We stretch vertically by a factor of 4, so the vertex is still at 4. We multiply the outside by a negative, so it flips top to bottom. So now instead of opening up, it opens down, and then we go up 2. So the vertex of our parabola is at 4, 2. So it's right here. And then, for instance, when x is 5. When x is 5, 5 minus 4 is 1. 1 squared is 1. 1 times -4 is -4. -4 plus 2 is -2. So when x is 5, y is -2. All right, so that's the second point, and that's all we needed. All right, so I just kind of tracked the vertex. I plotted my vertex, and then I just went 1 to either the right or to the left, and then just crunched the number, right? And so we only needed the 2 points for this. All right, let's check it. Okay, I don't think we wrote anything here either. So for like my 3 p.m. and 4 p.m., we didn't really need to write anything. It was just going through concepts. Hopefully, you're able to take advantage of like these sessions and you can use them. If there aren't any burning questions, we're actually going to end the session here. Okay, guys, you guys were awesome. And from one beautiful mind to another, enjoy the rest of your day. Take care. Peace, guys.